Hi, my name is Aidan Stark, and this is my ENME 351 Electronics and Instrumentation 2 project. What I have with me here today is a model train setup. Here, I have two trains which are each independently controlled with their own internal motors. These trains, as they travel down the track, will regulate the distance between them using this ultrasonic sensor and reflecting plate. This will measure the distance between the trains, and then they will maintain a set equilibrium distance between them. Over here on my breadboard, I have two objects for user input. A push button, which will start and stop the trains, and a potentiometer that allows the user to regulate what the set equilibrium distance is between the trains. I also have an inverter and an H-bridge motor driver, which controls the trains. Over here, I have a mechanical switch on the track, which controls which direction the trains will go. Controlling this switch, I have a stepper motor with its corresponding H-bridge motor driver. Further down the track, I have a digital servo which controls this gate. This gate will be raised when the trains are not in motion and lowered when the trains are in motion. At both ends of the track, I have these Hall effect sensors. On the sides of the train, I have rare earth neodyme magnets, and this Hall effect sensor will detect the magnetic waves from those magnets. Once this is detected, it will notify the Arduino to stop the trains, preventing the trains from running off the track. With the press of this push button, the trains will now begin their operation. The trains begin to go down the track, maintaining the equilibrium distance between them using the ultrasonic sensor. They will trigger this Hall effect sensor, which will switch the track via the stepper motor. The trains will now hit this Hall effect sensor, and the trains will go back down the other end of the track. They will stop at this Hall effect sensor. The trains are now stopped. The stepper motor switches the track back to its default position, and the servo re-raises the gate since the trains are no longer in operation. In this state, the user can still move the trains, and the trains will continue to maintain their equilibrium distance. Using potentiometer, I am now controlling that equilibrium distance between the trains, increasing and decreasing it. I will now demonstrate the trains traveling one more time, but this time as they travel, I will be modulating the potentiometer and controlling the equilibrium distance between the trains. I begin the program with the push button. Trains begin to go down the track. I'm now decreasing the equilibrium distance between the trains, so they should be very close. I trigger the Hall effect sensor, the track switch switches. I'm now increasing the distance between the trains, so they're beginning to spread out. They continue to spread out, and now I'm going to decrease the equilibrium distance one more time, and the train begins to catch up. They stop at the Hall effect sensor. I will now show the graphical component of in processing. This is a processing screen for my project. Here I display the various metrics of data from the sensors in my project. On the far right, I'm displaying whether or not the Hall effect sensors are currently being triggered or not. Currently, neither of the Hall effect sensors are listed as active. But if I move the trains, I can trigger the Hall effect sensors, changing the information to true. In the center here, I have two metrics of data. This is the user-defined equilibrium distance between the trains, and this is the measured distance between the trains from the ultrasonic sensor. And on the far left, I am displaying whether or not the program is stopped or running. If I push the push button, then the program will display as running. And then in the middle of the screen, I have a graphical representation of the equilibrium distance and the distance between the trains. This is a scale bar from 5 centimeters to 20 centimeters. The green dot is a representation of the user-defined equilibrium distance, and the blue dot is the current ultrasonic sensor measured distance between the trains. As I control the potentiometer, I can change what the user-defined equilibrium distance is, and the blue dot following it is showing the trains trying to match that set distance. That is my project. Thank you for watching.